I have a to-do list application where the user can either sign up or log in. Now it's very important whenever you accept sensitive information from the user, such as their password, that it be sent over a secure connection so that it's encrypted instead of sent as plain text. So you would want to use HTTPS for any login forms or sign up forms in your application. So let me try submitting this. So I log in. Now it's quite common after signing in a user to switch back to a normal HTTP request because you no longer require the user to submit sensitive information. However, if you're doing this, your application is likely vulnerable to session hijacking. This technique, specifically known as sidejacking, was popularized a couple of years ago by this Firefox extension Firesheep. Basically, you would just have to go to a public Wi-Fi location such as a coffee shop, and this would monitor the local network traffic and allow you to hijack a user's session as long as it took place over an insecure connection. This blog post does a really great job explaining the problem, so you might want to give it a read. I'll link to it in the show notes. Now let me demonstrate how a hacker might hijack a session for your Rails application. I won't be using Firesheep here, but instead the TCP dump command, which comes with macOS 10, and this or something similar is available in pretty much all platforms. Now we can use this command to inspect traffic on a network interface, usually EN0, 1, or 2, but here I'm going to use LO0 for the local host because that is where the Rails application is running here in development. I'll also pass in the -A flag to give me the output in ASCII text. And one more thing, it's important to run this under sudo so it has root privileges. Next, I just need to go to my local Rails application where I'm signed in and try reloading a couple of times to generate some traffic. And then back in the TCP dump output, I can do a search for cookie to find the request and the cookie that was used to access my Rails application. So here is that cookie for the session. Now you can stop TCP dump by hitting Control-C, and then with that info we can make a request. I'll just use curl here to our local Rails application, and normally what I get is currently not logged in as the output. But if I pass in that cookie as a header in here, just paste it in, then it says I'm currently logged in as Ryan B, and there are my tasks. So this is pretty crazy. Anyone on the same network can easily hijack a user's session unless they're using HTTPS, so that way the entire request is encrypted, including the cookies. So how do we enforce this in our Rails app? Well, if you check out the production config file of your Rails application, you'll likely see this comment here setting force SSL to true. So if you uncomment this, it will require that every request in a Rails application use HTTPS or redirect otherwise. Now I'm going to temporarily enable the setting in development as well so that we can test it there to see the effects. So now after restarting the Rails app, if I try making an HTTP request to my Rails application, it gets redirected to HTTPS. Now it's normally pretty difficult to test this HTTPS behavior in development. I am using a combination of Nginx and POW to get this working, and I'll explain how to do that in this week's Pro episode. Now this force SSL setting assumes you want to make every page of your application secure, but what if you don't want that? What if you only want to enable SSL on certain parts of your site? Well, in that case, you probably won't use force SSL, but instead restrict it at the controller level. But then you're vulnerable to session hijacking because the cookies are sent in the clear. One solution to this is to go into wherever you log the user in, and instead of assigning one cookie here, set 2 instead and make 1 secure. So in this app, my login behavior is inside of a sessions controller create action, and in addition to storing the user ID in the session here, I also want to store it inside of a cookie. Now I'm going to make this cookie signed so that the user can't modify it, and I'll call it secure user ID. Now I'll mark this cookie as secure so it doesn't get passed in an unsecure connection, and I'll set the value to something like secure user ID. And then in case the user signs out, which is in this destroy action, I'll delete that cookie, cookies.delete, and then pass in that secure user ID cookie there. So now with that extra cookie in place, I can check that whenever I fetch the user, which happens inside of my application controller current user method here. So what I want to do here is make sure the current request is not on a secure connection, or if it is, then we have to check that secure cookie. So we can do so by calling cookies signed secure user ID, and then see if it matches secure and then the session user ID. So with this in place, if the session is hijacked, the hijacker will not be able to access the secure pages as that user. So let's try this out. Now when I log in through the application, it's going to create two cookies, one secure and another for the insecure connections. So from the user's perspective, when the app switches between HTTP and HTTPS, they're always logged in. But now when someone tries to hijack the session, all they can fetch is the insecure cookie. This will still allow them to connect as that user to a normal HTTP request. You can see they're still as that user. But if they try fetching a page through HTTPS and I have to pass in the -K option for the site certificate issue, then it says they're currently not logged in because that secure cookie doesn't match. So with this technique, a hijacker can still act as another user on normal HTTP requests, but for HTTPS requests, it will not allow them access. So be sure to always enforce SSL on pages that you do not want a hijacker to access. Well, that's it for this episode on this important security issue. Thanks for watching. This week's Pro episode is all about adding HTTPS to your application. There I show how to set it up on your local machine, configure rack SSL, install certificates in production, and much more. To watch that episode and all other Pro and Revised episodes, just head on over to railscast.com/pro and then sign up there for just $9 per month.